O and E.
Who invented mathematics? Mathematics has no single inventor, but ancient civilizations shaped it. Ancient Egypt and Mesopotamia, 3000 BC, used math for building, trade, and astronomy. Greek mathematicians, 600 BC, Pythagoras, Euclid, Archimedes. They formalized math as a science. Indian mathematicians, 300 AD, invented zero advanced algebra. Arab mathematicians, 800 AD, refined algebra, introduced it to Europe. In modern times, mathematics evolved into what we study today. Mathematics is a collective human achievement, not invented, but discovered and evolved.
A 7-year-old was punished with a math problem. Add all numbers from 1 to 100. A tough problem for such a young kid. But he thought for a while and gave the correct answer, 5,050. How did he do it so fast? He realized sum of first and last number was 101, same for second and second last, and so on up to 50 and 51. So how many 101 pairs are there in total? There are 50 such pairs. So the sum must be 50 times 101 or 5,050. That kid grew up to become one of the greatest mathematicians of all time, Carl Friedrich Gauss.
To multiply 85 into 85. Take the first digit, which is 8, and multiply it by 8 plus 1, which is 9. Multiply 8 into 9, which is 72. Take the two fives from the units place and multiply them. 5 into 5 is 25. Put the two together and what's your answer? 7225.
What is the only number with all its letters in alphabetical order? Can you figure it out? The number is 40. F-O-R-T-Y. Now, what about instead of in alphabetical order, it's reverse alphabetical order? Again, there's only one such number. Can you figure it out? It's 1. O and E.
Good afternoon, everyone. On behalf of the PG program of mathematics, I, R. Pavitra, and my co-host S. Dharani from 2nd MSc Mathematics extend a warm and cheerful welcome to each one of you joining us virtually for today's webinar on innovative approaches in teaching and learning mathematics through applications. We are privileged to have with us our respected dignitaries, honorable faculty members, dear students, and all the participants who have taken time to join us. Your presence makes this event all more meaningful. To formally invite everyone, I call upon Ms. Lakshmi Priya of 2nd MSc Mathematics to deliver the welcome address.
Good afternoon, respected dignitaries, faculty members, and dear students. It is with immense pleasure and honor that I welcome each one of you to this webinar on innovative approaches in teaching and learning mathematics through application. Today we gather to explore how mathematics, the language of logic and patterns, can transcend traditional methods and become more engaging, practical, and impactful through innovative applications. First and foremost, we extend our heartfelt welcome to General Secretary and Correspondent Mr. Manjat Singh Nair, whose constant guidance and unwavering commitment drive the growth and success of our institution. A warm welcome to our esteemed principal in charge, Dr. R.M. Irilarasi, whose visionary leadership and support continue to inspire us toward academic excellence. We also extend our warm welcome to Dr. P.V. Kumaraguru, SFS, Vice Principal, for his dedicated efforts in ensuring the smooth functioning and progress of our academic and administrative endeavors. A warm welcome to Dr. Swati Paliwal, Dean of Academics, for a relentless pursuit of academic innovation and excellence. We are pleased to welcome Dr. J. Jayanti, Dean, School of Sciences, whose guidance and encouragement play a vital role in fostering a thriving academic environment. Today, we are honored to have distinguished guests with us. We extend a special and warm welcome to our chief guest, Dr. T.N. Shanmugam, retired professor at Anna University, whose remarkable contribution to education and research have left a lasting impact. We are equally delighted to welcome Dr. Kavita Sutar Deshpande, freelance mathematician and visiting faculty at CMI, whose expertise and insights enrich the academic community wherever she goes. Last but not least, a warm welcome to our faculty members, students, and enthusiastic participants whose presence make this gathering meaningful and vibrant. May this event serve as a platform for learning, sharing, and inspiration for all of us. Thank you.
Thank you, Ms. Lakshmi Priya, for those warm words of welcome. To begin the program with, privileged to have with us our respected Dr. K. Manikandan, Assistant Professor, Head of the PG Department of Mathematics. I now request Sir to share a few words about our department.
The postgraduate Department of Mathematics was established in 2015 with the vision of strong analytical skills, logical reasoning, and problem-solving ability among students. Over 300 students have graduated from the department, and our alumni network grows stronger and stronger. The department has been actively involved in academic and co-curricular activities that enrich both knowledge and application. The department has a vibrant student association led by elected office bearers, which organizes and coordinates several student-centered programs throughout the year. One such as the Intercollegiate Fest Math Happens 2025, which is recently witnessed the enthusiastic participation of over 300 students from the various colleges. The broaden learning beyond the classroom, the department organizes industrial visits, hands-on workshops such as data visualization using Python, and a training session for competitive examination like the CSIR NET. These initiatives equip students with the practical exposure and prepare them for both research and career industry. Our students have consistently brought laurel to the department by winning prizes in intercollegiate and interdepartmental competitions. In addition, the department proudly celebrates important occasions such as Pi Day, fostering a culture of the appreciation of mathematics. Many of our alumni have been successfully placed in prestigious institutions for higher studies as well as in reputed companies, reflecting the academic strength and holistic development offered by the Department of PG Maths. Thank you.
Thank you, sir. Now moving ahead with our technical session, I take pleasure in inviting Dr. T. Harikrishnan, Assistant Professor, PG Department of Mathematics, GNC, to introduce our first resource person, Dr. T. N. Shanmugam.
It is a great honor and privilege to introduce our distinguished resource person, Professor Dr. Tirunelveli Nelliyappan. Sir has devoted his life to mathematics, research, and education. His academic journey is truly inspiring. From his early studies at Guru Nanak College at 1971 and 72 batch, he went on to complete his BSc Mathematics, the New College Chennai, followed by MSc and MPhil at the prestigious Ramanujam Institute, the first batch in 1976-79. He pursued research at the Tata Institute of Fundamental Research, PAN, and earned his PhD in mathematics from Anna University in 1990. As a professor of mathematics at Anna University, Sir has made an immense contribution to academia. He has published more than 150 research papers in reputed national and international journals and has guided 10 PhD scholars in mathematics and computer science. His specialization lies in geometric function theory, a branch of complex analysis, and he has built a strong research collaboration with the scholars in Japan, Malaysia, Norway, South Korea, intellectual property rights, Anna University, and play a pioneering role in patent awareness and training programs. Under his leadership, CIPO facilitated more than 105 patent filings. He authored the book, The What, Why, and How the Intellectual Property Rights in both English and Tamil, as well as 3 volumes of glimpses of patents in the field of electronics and information technology. He also served as a founder, dean of the University of College of Engineering, Kochi, where he was instrumental in establishing infrastructure and academia system. After his superannuation in the year 2015 from Anna University, he worked as a visiting professor in the National Institute of Technology, Nagla, and established the IPO cell apart from teaching courses for MSc Data Analytics. He still travels to lecture on mathematics, intellectual property rights, Internet of Thinking, motivating the students in learning mathematics across Tamil Nadu and also in other countries. He was one of a domain expert appointed by the government of Tamil Nadu for the revised higher secondary mathematics. Presently, he is the honorary secretary of the 92-year-old school, C.D. Noyagam T. Nagar Higher Secondary School. He frequently writes mathematical articles for Dinamalar Pattam in Tamil with an objective to popularize mathematics among the young children. He also has literacy interest. Because of that, he gives a series of lectures on Aranul Tirikadagam, Inda Nul Padinen Kirkanakil Nulkalin. Penned under a pen name, Sendamudanin, several poems and released book entitled En Parvayil Tamil Kavadai. During the Corona lockdown, he published 3 books as an Amazon Kindle version entitled Sendamudanin Tavida Kavadaigal, Sendamudanin Corona Kala Kolangalam Kanikamu, Sendamundana Puran. Mahakavi Erode Tamil Anban, a Savitmi Academy Awardee, published Sendamudanin Devida poems Amuda Nilayam on 5/9/2020. Once again, we extend our warm welcome to our esteemed chief guest. Sir, we are honored to have you with us today. Now, stage is yours.
So, thank you very much for the nice introduction. And as it was mentioned, I'm happy to be associated with the activities of my alma mater. In fact, in the Guru Nanak College, I was in the very first set student of 1971 to 72, and I did only the pre-university class. And later I shifted for a different college for the BSc and so on. And I'm happy to be associated with this thing for the knowledge sharing. So I think let me go to my talk. I think I need to. Am I visible to all? Hello?
Yes, sir.
Yes, sir.
Am I visible? Okay, so I'm just going to open my PowerPoint slide. For that, I think I need to make a share, right? Yeah. I'll be sharing this. Yeah, is it visible? Yeah, is the screen visible? So kindly respond for initial 2-3 minutes so that I can, yeah. So thank you. So our traditional welcome in Tamil, Vanakkam, Nanbargale. My thanks, I keep it in record. My thanks to the head of the department, Dr. Manikandan and Dr. T. Hari Krishnan of the Department of Mathematics, Guru Nanak College, for extending an invitation to speak before you here. Of course, I have given the title as Mathematics Around Our Life because even in their introductory thing before the event started, so they showed a small clipping about the mathematics. So the mathematics is not invented by a single individual. It came just from around our life. So therefore, I would like to point out to the people so how it is connected and how you could observe the mathematics even from a very small ant and also on the bigger aeroplane. And for everybody, it is their ambition to go higher and higher in whatever the life they choose. But for that, a ladder is necessary. I think everybody will agree with me. So particularly, if you want to be more scientifically involved, and as a scientist, you wanted to develop yourself, scientists or the application scientists like engineers or technologists, everybody requires the ladder of mathematics. The ladder is the mathematics on which only people can go higher and higher in search of the truth through science. Okay. So, and therefore, mathematics is very, very vital. Now, what is generally mathematics? So, I tried to give a little definition. It may not be exhaustive. Mathematics is only a tool to represent and what happened? Yeah. And through it can represent the physical phenomena, chemical phenomena, sociological phenomena, because most of the sociological problem involves only the data and how to process the data. So there comes the mathematics and the history also, because in the history you need to find out the dates on which something can happen, even to compute the date of a tree. You are doing the carbon dating, which is a half-life. Okay, so there also an amount of mathematics is being used apart from other sciences, geographical, medical, and engineering principles, and through three things. One is the numbers, the another is a variable, and the third one is a equation. Because it is very easy to analyze the different principles and you could come to a conclusion rather than attacking the problem per se. So we need to make a model, and that model is given by the so many principles, established principle. It may be a principle coming out of the physics or chemistry or biology and whatever it is. And then you make a model, and the model will be invariably equations. The equations may be algebraic equations or differential equations, which encompasses the partial differential equations too, but more so it is the partial differential equations that serves as a mathematical model, and the solution of that you need to interpret appropriately depending upon the boundary conditions. Sorry. So mathematics is going to be all pervading in our life, okay? Because now that everybody was given a mobile phone, you do everything by a touch, right? But even to get that technology, a lot of mathematics is being used. Okay, I will show you one by one where the mathematics are being used. But before that, as the title of the seminar is going to be the innovative teaching as well as the learning process. One can do the teaching provided there are learners, right? And what is more important is certain habits, because given any two persons, their learning habits may not be same. It will be different for different people. So we need to know about the learning habits and the teaching also. You know that whoever teaches 2 plus 2 is always 4. There is no doubt about it. But how does the two different teachers, they differentiate themselves? It is the way by which they try to teach you what is 2 plus 2. Okay, that 2 plus 2 is only an example. Okay, at the lower level schools. Okay, so the teaching also, or a teacher also, has to develop lot of habits to shine as a great teacher, or the teacher who will be appreciated by the students, attracting their attentions. For all these things, it is today in a modern world with so many electronic gadgets, it's very difficult to be a really an attractive teacher, because for everything people hang on to Google. So whatever I say, whatever the classroom teacher says, immediately they can find out whether what we are telling is a true or a false one. Immediately they can contradict. And therefore, we also as teachers, we need to be more equipped with the modern technological tools and the informations. But then what are the strategies you need to follow? And then the strategies particularly to be a mathematics teacher. Okay, so these are the things one needs to know first. And all these things I'm just going to tell you in another couple of slides out of my own experience as a mathematics teacher. For the last 45 years I have been teaching. Now I am 71 years old. I started teaching at the age of 25. So what are the different learning habits? That learning habits can be grouped into the following terminologies. One is, one must need to identify things. That is called the identification, because when you are a kid, you please remember, so how you learned the colors, how you learned the alphabets, how you learned the other these things. It is only through the identification. Because if somebody asks you, so what is green color? There was no definition for the you can impose to the child or a children. And therefore, somebody will come and say, oh, this is, so the shirt which I am wearing is a blue color. So the next time a similar one, when the students or the children finds, so they will identify. So the first learning comes only out of the identification. And after the identification, the mathematics starts through what is called the arithmetic. Okay. Arithmetics, you know, the basic operations, addition, multiplication, division, etc., which extends the square root, and then later on it develops into an analysis and algebra analysis, etc. But then the third part of the learning habit comes through what is the generalization. The learning of mathematics is largely through generalization, because you prove for certain cases and then you try to ask the question, if it is true for this, will it be true for that? So you will be given a set of conditions, you have the conclusion. If these conditions follows, then that conclusions will come through. If it doesn't follow, what will be the alternate conclusion? So that is how people try to generalize, and so many inventions had happened, and that is what our forefathers like Euler, Cantor, and so many people have given several theorems to us. So largely, whether you study mathematics or any new studies, the habits can be classified into the three parts. You must be able to identify, you must be able to work with the little arithmetic, and you must be able to generalize things. Generalize in a logical way. The logical way by which I mean it is with a given set of conditions. The conditions may be varying, right? Say, for example, I can always say that 2 plus 3 equal to what? 5. But at the same time, I can also say that 2 plus 3 is 0. It may not be a laughing stock, but what is the logic you are going to attach? Because many people here are a postgraduate student, so you will agree with me for the modular arithmetic. If it is base 10, then you know 2 plus 3 is 5. But on the other hand, with respect to modulo 5 operation, then 2 plus 3 is 5. Divide the 5 by 5, the remainder you take, which is 0. So therefore, there is a context. So most of our learnings are context sensitive. Maybe people who are aware of the discrete mathematics should be aware of this context free, context sensitive, and so on. Okay. And now what is an identification? Let me explain to that. So if I am giving you this picture, you could immediately identify that is at least a triangle, if not the right angle triangle. This is what? So for some people, it may be a circle. For some people, it may be a disc. It is what you look at. Whether you are looking at the periphery or the purple one or the red one. If you are looking at the red one, then it is a disc. When we are looking at the boundary and the purple color, then it is a circle. What about this? This is a pentagon, because it has 5 sides, right? Okay. Now suppose if I give this, it is totally unfamiliar to you right now. So therefore you cannot name it. And so if we give a name to it now, and later on if in some cases you get a similar picture, you could know, oh, this is what? Oh, we have seen there. Or somebody like Shanmugam came and gave this shape. So named it. Okay. So this is what is identification. For the first time when you see, it may not be known to you. But as you go further and further, then it sticks to your mind. Like how we all memorized the Tirukural and all from the school. And the later you know that the arithmetic was is needed. But for the basics for the arithmetic is what? The different number systems. What are the different number systems which you know already, but why it came and so on. First is the counting number, then the integer, then the rationals and the irrationals, and rational and irrational put together, it is a real number system. Then the real number system, you developed a complex number system, and you know that complex number system is algebraically closed, whereas the real number system is not algebraically closed. And so therefore, after developing every number system, there was a question. And to answer that question, the new number system was developed. And please remember, the number system did not stop with the complex number system, because in order to do the spatial mechanics, space dynamics, rocket engineering, this complex number system won't help, because complex number system works only in the two-dimensional thing. But the rocket science has to be on the three-dimensional one, and therefore you require a bigger number system which is not much familiar with the student population. That's called the quaternions. The quaternions is given by, it's in the fourth dimensional numbers system. Okay, and the quaternions was developed by Hamilton, William Rowan Hamilton, and he is the person. So for the arithmetic, the basic things are what? It is the number system, and you got developing the number system. Please remember, even beyond quaternions, one could develop a number system. Okay, one could develop. I stop with that because you think over, is there any number system beyond the quaternions? Okay, and its uses, etc. Okay. And now the next thing is coming to the generalization. I'll ask you a very simple question, so somebody can unmute and answer. How many numbers are there, m and n, so that their product is the same as the sum? At least few people, you could unmute and answer. One or two people. My dear students? Yes? Is there anybody? Okay. At least one interaction. One interaction? No? Okay. Okay. So whenever we ask this question, people will immediately say there are only two such things. Taking into account that m and n are 0 or m and n are 2. Because 2 plus 2 is 4, 2 into 2 is 4. And 0 plus 0 is 0, 0 into 0 is 0. And please remember, the question is how many numbers? It is not how many positive integers. Okay. So therefore, you need to be more observant. Okay. But the proof for this is, it is in fact, you have an infinite number of solutions for this, because 3 into 1.5, you have 3 plus 1.5. Both are same. So if you look at the solutions only in the integers, then positive integers, then there are only two solutions. But if you widen your search base, then there are infinite number of solutions. That is how the life also teaches. If you look at for any of your problem locally, you may not find a solution. And therefore, you need to widen your domain so that you will find a solution for every problem. Next is 4 into 1 and 1/3 is 4 plus 1 and 1/3. 5 into 1 and 1/4 is 5 plus 1 and 1/4, etc. Generalizing this, you will have n plus 1 into 1 and 1 by n is the same as n plus 1 plus 1 and 1 by n. So therefore, whatever be n integers, everything is a solution for the question which I asked. And I just want to tell you that this question...
Recording in progress.
Yeah. Okay. This question is not by me. It is in fact by one of my research collaborator of Norway, Professor Frode Ronning. So this question came up when we were discussing over a coffee some other problem. And then the high school, this was posed only as a high school question. Okay, so it was through Professor Ronning I got this. So I thank him for permitting me to use it in the lecture. Now, what are the strategies? Okay, the strategy will be for different people, because each one of the teacher has their own style of teaching, and in fact that has to be developed. Okay, because we all learn through our teachers, but then we need to augment whatever technique we have learned from our teachers. We need to put our own experience, so and then develop your own methods. Okay, so that is how you go step by step, etc. So first is, before you start off, you need to start off on any topic. You need to give a proper introduction. You need to give a proper introduction, and then, then you need to develop the content suitably to the audience. Then the rigor, that is how reliable your content is. So you cannot just like that take it from a book or another book. You need to read those things, and you please write down with your own input, with your own words, and present it. Then the medium, I mean, it is not pertaining to the language. The medium, I mean, how you are going to teach. Because in a regular classroom teaching, it is a chalk and duster. But nowadays, in the modern era, you could develop it like what I am doing it now, okay, as an online lecture. Or you could record all your these things, you could post it on your YouTube, maybe for free, or you could do a business with it. Okay. And what are the different medium over which you are going to talk on, or you are going to teach on? That matters. Then the time. If you are given 1 hour time, you must restrict it to 55 minutes, and then you must leave the 5 minutes for the questions, because the audience will have definitely a question. So what is a introduction? A nice introduction of the concept. When you give before your lecture, even the classroom teaching also should be made like this. It should attract the audience towards your talk or the lecture. you must prepare the content in such a way that it should impress the audience. Please give the attention to the rigorousness of the contents. And the medium, I have told you already, the choice of medium also plays an important role in the teaching, like the chalk and talk, which is a regular thing, OHP sheet, now defunct. Nobody uses the OHP sheets, only the PowerPoint presentations they give. And also over the internet. And that's what I'm doing it now. So finally, the time management. Okay. And one more important thing is, everybody has got their brain, but the assimilation time varies from person to person. So therefore, we never, as a teacher, nobody should assume that the students cannot understand this, because it is the duty of the teacher to make the student understand. And that is why we are, some people are teachers and some are the learning students. Okay. So these things we must avoid. Okay. Everybody knows, but the only thing is, as a teacher, we must be able to grab their attention and then feed them with the correct information and why they need to study, why that particular subject is necessary, not just to get their job and fat salary, but for the livelihood, for the innovations, etc. Okay, so how to develop this? How to develop all these things? So you need to have the teaching habits, as I told you in a earlier slide. All these things coupled with my experience only. The first thing is, you must have the habit of recycling. Tamil chonnaka திரும்ப திரும்ப சொல்றது. Okay, this is what we practice in the schools, where you learned all your multiplication table. We learned only through the recycling, right? And the reason for having or developing this habit is, then only it will stick onto your mind. Okay, but how, or what is the principle behind it? If you want to make sure they never forget, that is, the audience, they should, if you as a teacher or an educator, if you want your ideas to stick in their listeners' mind, you need to recycle the point which you feel that it should go into their mind and it should kindle their mind. Okay, so therefore this recycling has to be done, some things daily, some things weekly, some things monthly also. The next habit is impress. In life, definitely we are impressing so many people for so many reasons. Always, everybody, whether independent of the gender criterion, everybody wants to show off a little. So as a teacher, you show off a little so that the students will have the confidence in you. So whatever you say will have a validity, right? So otherwise, if you are just, the students will be at one end, you will be looking at the board and writing something, means there will be a disconnect. There will be a disconnect of the teacher from the students. So such things should not be there. The teacher and the students must work in tandem. Work in tandem. So then only you could impart the knowledge, and the teacher can, or the learner can receive the knowledge. Okay, but for that the impression, because you need to give a good impression to your listener. You should develop a confidence that whatever you speak is not just blabbering, or it is not just repeating from whatever is in the text or whatever is in the internet, because that they themselves can do it. But what is your this thing? So that is what comes in the impress. The third one is the transition, because this is to make the knowledge transformation flow one has to create. Because if you say in the previous minute something and the next minute which is totally unconnected thing, so then the people or the listeners cannot connect. They will think, oh, he told something at that time and now he is telling so contradictory. So therefore, they may not be able to retain which to retain. So therefore, the talk or the lecture has to be having a flow of thoughts. And are you going to keep them engaged? So this transition technique will keep all your listeners cooked down to your talk whenever you are in the classroom in the personal thing. Okay. And therefore, you need to seek some strategic tools to connect each segment and then stitch it together. Stitch it together. And the fourth point is that personalize it. That is, in order to make things real, you are not telling something out of the world, something which is imaginary. No, except the imaginary number, which is we denote it by I. Everything should be, you must make it real, because whatever topic you speak, you need to create a model out of it, and the students or the listener, they themselves must be able to create a model for a similar problem later using your model. Okay, so show them a lesson from your life or your experience. So that is what is called the personalizing things. And all these personalizing things are independent. It is exclusively of the teacher. One cannot copy. Okay, your experience I cannot copy. My experience you cannot copy. But you could learn a lesson from experience. Okay, and finally apply. Because most of the mathematics people, they ask the question, why all these things are found out. Okay, but if I am permitted to speak in a local, our own language, as a student, you would have felt many times, இதெல்லாம் யாருதையா கண்டுபிடிச்சு நம்ம கழுத்த இருக்கிறோம் அப்படிங்கிற ஃபீல் ஆஸ் எ ஸ்டூடெண்ட் எனக்கும் வந்தது. இதே குருநானக் காலேஜில் நான் படிக்கும்போது எனக்கும் வந்தது. So everyone will have that. So how to alleviate that feeling? The feeling is the teacher must be equipped with where it is being applied. We cannot just like that write a differential equation. You write the differential equation, solve the equation, you can explain the methods, write down the auxiliary equation, find out the complementary function. All these things are method, right? But what does that differential equation tells? So that is what is lacking in most of the mathematics classes. So you need to tell them that this differential equation is a model for this particular problem. But the next question will come, where from I can get? Is there any book? No, there is no single book available. For that, as an experienced teachers, we need to correlate the things. We need to correlate the things. And then we try to model it. Okay. And that is what I'm going to explain to you. How to make a model out of whatever is happening around our life. Okay. Right. So, how to remember these teaching habits? I'll give a name to it, taking the first letter of each of the word. T, A, R, I, and P. It's called the tariff. So, tariff is a habit. Tariff is a teaching habit. So, what does the T stands for? Transition. A stands for application. R stands for recycling. I stands for impressing. And P stands for personalizing. So whatever topic you teach, you try to apply the tariff, probably you might get a good audience. I mean, that is, it is out of my experience, I have gathered that things. Okay. And now coming back to the mathematics, you will not easily believe that what I'm going to tell you now, whatever be the mathematical problem, the entire world problem, whether irrespective of the subjects, it may be an economic problem, it may be a medical problem, all the problems can be grouped only into 8 differential equations. Only 8 differential equations. That's why I call it as 8 wonders of the scientific or the mathematical world. What is the first thing? It is the energy mass equation. You know, it is the Einstein's equation. E equal to mc square. You can make an electricity out of this equation through this equation, or an atomic bomb designed by Oppenheimer way back in 1933. Okay, the bomb was made. That was also through this. The next thing is the Newton's second law. You know that force equal to mass into the acceleration. Bodies move around the universe because this equation forces them. The next thing is the gravitational equations. F equal to g into m1 m2 divided by r square, because our earth goes around the sun through this equation that is characterized by this equation. And this is the black hole entropy, a palpable infinitesimal volume and the infinite mass of the universe are connected by this black hole entropy. And this is the internet revolution. H is equal to minus summation pi and log pk, pk into log pk. Of course, one has to explain the equation with its parameter, but since I have only a limited time, I cannot spend on lecturing on each of the things. I just want to show you the equation, the 8 equations which governs the world. Then the Maxwell's equation, which is the basis for the electrical engineering. Without this Maxwell's equation, no electrical engineer can survive. The rhythm of behind the cosmic dance. And then the Schrodinger equation. And finally, the school level equation, Euler's equation, e power I pi equal to -1, that has been rearranged like this. And it gives a great philosophy. You know, as a mathematician, you don't know the exact value of E. You can all say that it lies between 2 and 3 as 2.718 and so on. And pi, you know the ratio of the circumference to the diameter of the plane circle, which is approximately 3.14 or 22/7, etc. But nobody knows the exact value. And I, you know, it is a imaginary number because it is the square root of a -1. A notation was given. And now, if you look at macroscopically, you don't know the value of each of the things. But if you know the art of arranging all the unknowns, E, I, pi, along with the negative sign, you know it is 1, and 1 is universal. So everything is known. So therefore, in life also, you should not be digging onto a microscopic level. So try to have a global view. So then you will understand the universe. Okay? So that is the philosophy the Euler's equation gives you. So as I told you earlier, whatever be the problem, you model from the scientific principles, it will come into one of these equations only. One of these equations only. And whatever equations you have studied so far, you could always bring that into one of these forms. Only thing is the representation for the E, M, and C might be different. Similarly, F may be different. That's all. Okay. So, with that thing, I'm once again coming to the teaching. The teachers need to know that no one expects them to have all the answers just because they are certified as a mathematics teacher. Even at this age, with so much experience, I still have a lot of questions for which I am still seeking. And there are a lot of questions posed by others for which I am still unable to give the answer. That's also I am doing the search. So teachers must have an attitude of a willingness to learn new concepts, new methodologies to be imparted to the students. That is, teachers must always be a dedicated student. Teachers must be the first student. So then the teaching and learning will go hand in hand. There are other steps also. I'll quickly go through. You must fit the lecture to the audience, as I told you earlier. Focus your topic. Prepare an outline that includes 5 to 9 major points you want to cover in one lecture. Organize your points for clarity. Select appropriate examples and illustrations. Present more than one side of an issue. And be sensitive to the other perspective. Repeat points whenever necessary. Be aware of your audience. Notice their feedback. This you may not able to feel when you are giving a lecture through the internet, because most of the people, they switch off their videos and the audios, and the teacher definitely will not know whether they are listening or not. Okay, so even I am also feeling that only. But when you are teaching face to face, you could understand that students' feeling from their body language. Similarly, the student also can feel from the body language of the teacher whether he is blabbering or he is very serious into his talk. So be enthusiastic. You don't have to be an entertainer, okay? But you should be excited by your teaching. Okay, you should enjoy first your this thing, then only others will start enjoying your talk or the materials. How do you plan your lecture? The structure must be like this. You have a concept, you must have the illustrations, and the illustrations can be of two kinds. One is the textual, and the another is a visual. Okay, so yeah, some drawing and some photos like that. And then the application, which is more important, because nowadays the present day students are more demanding, because unless it is useful elsewhere, they will not easily accept. Otherwise, what they will think is, so every mathematics is available in the Google. If I know how to give a input of a function, one can find the integration very easily. So why should I strain my mind? So therefore, you should know that environment. Accordingly, we need to plan and modify our lectures. And the problems and the homework needs to be given. And the choice of the problem, invariably, most of the teachers, they inside the classroom, they do the worked out examples and then give the exercise to the students himself. But I advocate the other way. You take up a problem in the exercise, you do it for the students, and then the worked out problem itself, in the previous day itself, you give them as a homework. Let them see the book and copy it. At least they will be equipped with their mind to listen to your talk, so that they will not sleep in the class and so on. Okay. So this might bring a good reputation to a teacher. If you solve an exercise problem inside the class, it will create a confidence for the students in your teachings. So try to illustrate an application for the problem. Consult various books. Don't depend on only one book just because it is a prescribed book. Use the library, use the internet, and form your own problem. So if there is a choice of changing something, please change and give it. So this will gather you more confidence in both teaching as well as the learning. Just look at this. Okay, so what do you see now? Can I get a reply from anybody? What could be the mathematics out of it? Any mathematical word? So, dear listeners, at least one or two, please.
Dr. Sir, actually the participants are muted. They can type the answers in the chat. So one of the participants has said topology.
Yeah, Mr. Ganesh, I think you.
Yes, sir.
What did you say?
Can you hear me, sir?
I think Mr. Ganesh is speaking, right?
Yes, sir. Can you hear me?
Yeah, please.
So,
you are a student or a faculty?
I'm faculty in Nanak College, sir. So I said the participants are muted by default because we are doing the online forum. They can type the answer in the chat.
Okay. Yeah. So I understand.
Yeah. One of the participants has typed topology as the answer to your question in the chat.
Oh, they said topology. Okay, fine.
Yes.
If they have studied the +2 in the state board syllabus, they should know what is the pattern of this curve. It is available in the +2 mathematics book they have. Okay, in fact, it was introduced by me because I was one of the domain expert for the +1, +2 book, mathematics book. So in that specifically, I included this, and in the training of the teachers around the Tamil Nadu, I gave this visual example for that. It is in fact called the Lissajous curve. Lissajous curve. It is given as a figure number 7.9 in their textbook. The equation of that in the parametric form is x is equal to 2 cos 3t and y equal to 3 sin 2t. Because this is given just to encourage their enthusiasm to think beyond a simple pendulum. Everybody knows about the simple pendulum and the harmonic motion, which has been taught even in the school, even by the physics teacher would have taught. And for the harmonic equation, the differential equations we normally give d square y by dx square plus something into y equal to 0, and solving, you get the sinusoidal solutions. So if you plot the curve, you get the pendulum motions and so on. It comes from the attractive force essentially. But this is if there is a multiple pendulums, how does the movement will be there? So because we want the students to think beyond what is there in the text. So then only the learning process will be instilled on them by themselves. So that was the idea. The Lissajous curve, it is also known as a Bowdish curve because Bowdish was the person first discussed this kind of a curve. So this is called the complex harmonic motion. Okay, because there is a two-way of oscillation. It is not in the simple pendulum, it is a simple oscillation. So how to characterize the multiple harmonic motion, multiple pendulum movement? This is the one. This is the model. Okay. It has been introduced in the +2, I think, in the +2 book itself. Okay. So I'm just repeating it here. So what are the metrics of interest? So in that case, how to calculate the frequency of the harmonic motion and the relative amplitude, phase, and all these things are a part of the communication theory. All these things are parts of the communication theory. Okay, right. But under the topic mathematics in our daily life, I have nearly about 10 topics, and I don't think I will be able to cover each and everything in a limited time. So I'll just tell you in few things, whatever I could do within the limited times. The thing which I wanted to discuss now first was mathematics in observing the path of ants. Probably every one of you would have seen the movement of ants, particularly before the rainy day starts. If you look at them, it will go in groups, but not like the human beings. The human beings will go abreast. They will not be going on a uniform line or an organized way, right? It's a most known thing. But the ants have some discipline. It will go in a path. It is not a straight line, but it will have turns this way, that way, and so on. Is it possible to write down the equation of that path? That was the question. But why? Why we should bother for the ants? You might ask. You will be surprised to know that the paths defining through a differential equation of these ants, the same equation only will define or will give you the deflection of a beam constructed for the bridges in our house itself. For any construction, there will be columns and beams. And if you have a beam, definitely if you are overloaded, it will deflect. It will deflect. But how to measure that deflection and how to characterize that deflection of the beam? That characterizing equation and the movement of the ant, they both are one and the same. That's a very surprising fact. Okay, so that I will explain to you now first. The next one will be, most of you would be traveling by the two-wheeler. In the two-wheeler, you have the shock absorber, right? Because our roads are bad. So unless your shock absorbers are good, then you cannot, you will be breaking your backbone. And the movement of the shock absorber gives a second order constant coefficient differential equation. That is the model. Similarly, mathematics in sports, particularly, I will be, if time permits, I will be discussing the two sports. One is in cricket, the another one is the football, because next year we are going to have a World Cup, right? 2026 World Cup football, organized by the three American countries, Canada, America, and Mexico. They organize, and it will be played there. Okay. And another thing is, everyone is having a mobile phone. In the mobile phone, you know who is calling. Do you know what is the mathematics behind that? So that I will explain to you. And then the cryptography, which is a hard subject, which is a very sought after subject nowadays, because everything has to be hidden, including your password has to be a hidden one, right? For banking transactions and booking a taxi, everywhere you get a passcode or a password you require. And how it is crypted? How it is crypted? What are the crypting essentials for through mathematics? And then in the internet age, we will be sending a lot of files from here to there. But unfortunately, the internet speed might be limited, or your capacity of your network may be limited, and therefore you cannot send a large file. And so you need to make a compression. So what is the mathematics of compressing an image? And when you are compressing, you need to be very careful, because when you uncompress, the image should not be distorted. So what is the transformation required? So that. And then mathematics behind certain measurements of a shape, and mathematics in aerofoil modeling, the plane, okay? And mathematics are there in the autonomous cars, that is the driverless cars. They are coming now. The Tesla is there. Tesla is a driverless car. Google cars are coming, and Mahindra is also the Indian innovations. That is also in very soon, when the roads are properly laid, autonomous cars necessity may be there. Okay, but for all these things, the backbone is mathematics. And you know that these are all, whatever I said, it's a part of our daily life. Okay, right. Now let me start. Just look at it. So hope you could see how the ants are moving, right? It is not going in a straight line. but it is going in a curved path. My question is how to find the equation of that curve. I need to have it as y equal to f of x with reference to some axis, because the ants are moving only on the floor, and therefore the floor can be taken as a two-dimensional space. So you could have a reference line x and y axis, a rectangular coordinate system, you could fix it. And therefore you have to write down the equation. But in order to write down the equation, you need to know some facts about the ants' movement. If you look at it closely, each of the ant, at every moment, it takes this turn or this turn, right? But then not very much distance, but it goes like this, like this. But why it is turning? That is the nature of the ant. And so you need to understand how the ants move, right? So you need to know a little bit of your, I'll call it as a zoology, right? Because it's a living thing, okay? So study of the ant, it is a zoological subject. If you look at it with the macroscopic eye, the ants will have two antennas on their head. Two antennas. And they are the sensors for it. And whenever there is an obstruction, when in the movement, if there is an obstruction, it will not hit the obstruction. Like a water, if there is an obstruction of a rock, it may not push, because such force, if it is there, it will push. If the force is minimal, what it will do is it will go sideways. So thereby creating an island. Okay. In the same way, the ant also, through its sensor, will observe the obstacle, and then it will change the course of their path. It is there we are going to make an assumption, and then we will be deriving the equation through a differential equation. Okay, right. So therefore, at every moment it takes a turn, and therefore there is a change in their acceleration. There is definitely a change in the velocity as well as the acceleration. So what is the acceleration? It is given by the second derivative with respect to the time, which we know through our basic calculus. So connect that. And the acceleration, sometimes it is in this direction, sometimes it is in this direction. And therefore, this is going to be the reference axis, right? The x and y axis, they are the perpendicular axis. And therefore, we approximate its movement, the variations of the acceleration in two different directions. So accordingly, the acceleration in the direction of x is assumed to be proportional to the small amount of the vertical distance it moved. Similarly, the acceleration along the vertical direction is proportional to the x direction. Okay. So with this basic assumption, we will write down the equation of the path. Because in mathematics, you need to make certain assumption. Because always if you look at it, in any mathematical theorems, if you have these conditions, then this is the conclusion. That's it. If it is not, then there might be a different conclusion. So most of our theorems follow this logic only. So ants are moving in a path where its acceleration in the direction of x is proportional to y and vice versa. So this is the point to be noted. And this comes from where? This is where the assumptions made through the observations from the zoological aspect of the ants' movement because of their sensors. Okay. And now when you have this principle, this can be modeled. This can be modeled. So what is the acceleration? In such case, we get a system of ordinary differential equations as follows. This is the acceleration in the direction of y, the vertical direction, which is proportional to x, means d square y by dt square equal to kx, d square x by dt square equal to ly. So you had the principle and you have the model, which is a parametric equation in x, y in terms of the t. Right? Okay. And now, if you try to solve this system of differential equation, you may get one equation because for x, you can substitute. From the first equation, x is nothing but 1 by k d square y by dt square. So substitute in the second equation, you will get the fourth degree ordinary differential equation, which involves the k and l, that is as follows. When you substitute, you could get it like this. Okay, so the k and l combined together, you could make it as something power 4 because in uniformity with the order of the equation. Okay. So that the solution you could get very easily. You know the technique of solving the ordinary differential equations of the higher ordinary differential equation with the constant coefficient through your auxiliary equations and a particular integral. In this case, there is no particular integral because it's a homogeneous equation. So you get a fourth order equation. So when you solve this equation, you will get m power 4 minus alpha power 4 equal to 0. So m equal to m square plus alpha square 0, m square minus alpha square 0. So two complex roots, two real roots. So you will get something e power plus the trigonometric terms you will get. Okay, so that's the explicit solution. But as I told you earlier, this fourth order equation, d power 4y by dt power 4 minus alpha power 4 into y, this form of the equation also can be interpreted to calculate the deflection of the beam in the civil engineering, particularly the structural engineering. So ஒரு எறும்பு போற பாதை ஒரு பீமுக்கு ரிலேட் ஆகுது. Therefore, this single equation can be interpreted for the movement of the ant as well as that. So therefore, every differential equation can be interpreted for more than one problem. Right? So that is the speciality of mathematical equations and mathematics itself. So it is a language. A language means one can interpret, everybody can interpret in their own way, but that should be a logic. That's it. Okay. So the beam reflections formula is given by, because why the deflection means it is the bending. Okay. So when you have a beam, if it is overloaded, definitely it will bend. Okay. Just like that. Imagine if you have, I think I don't know the correct terminology in English. தமிழ்ல துணி துவைச்சி வெளியில கொடி காய போட்டீங்கன்னு வச்சுக்கோங்க. First day it will be in the form of a straight line. From the second day and third day, it will be bending, right? The same way. The same way for the bridges also. If it is overloaded, it will bend. And for calculating that bending moments and all, this particular equation is needed. That's where the application. Okay? Right. Thank you. Next. As I told you in the shock absorber, this is the way the shock absorber looks like. Okay? What will happen is, if you are traveling in a pothole, this is what will happen. What will happen is, there is a mass, the black color, and there is a spring. So, and that is connected to the dash point in the wheel. Okay. So, when the wheel goes into the pothole, so the mass presses the spring and it will compress. And once you are out of the pothole, the spring release. If it is not releasing, your shock absorber is dead. Okay. So it releases. And then you will not feel the shock as a rider or the pillion rider. You will not feel the shock. Now the question is how you need to characterize this motion. You know that this motion was only vertical motion. There is no horizontal motion. So what happens is, the equation of the motion described in terms of the displacement as k into dx by dt, the variations of the x. So the damping force to restore, you require a damping force, right, to the dash point, and nx, the restoring force resulting from the spring, they are all constants. Then the equation of the motion, we need to get it through the F equal to ma. What is that equation? It is the Newton's second law. So what you get is m into d square x by dt square equal to minus k dx by dt minus nx. So when you are simplifying, you get the constant coefficient, second order constant coefficient homogeneous equation. So you would have seen lots and lots of constant coefficient homogeneous equations in your school itself. And please remember, every equation can represent the movement of the shock absorber. Next time when you are riding a bike, and if you are looking at the shock absorber, remember this differential equation. So it will stick onto your mind. This is the equation which is working on your bike shock absorber, right? So therefore, mathematics is an interesting language, as I told you earlier. The Mr. Harikrishnan, how long I can go?
Sir, if possible, is it okay to finish in the next 5 minutes, sir?
Okay, so then I think I will finish it off with this mobile phone, because most of the people are postgraduates only, right?
Yeah.
Yeah. So they would have studied Fourier transformation. So therefore, I'll go for this. With this, I think I will complete the talk. So to understand the mathematics behind the caller ID, you must recall your Fourier transformation. So I think most of you would have studied, at least in your BSc, the transformation, the Laplace transformation and the Fourier transformation, which is a very, very important tool in the signal processing area. Okay, so this is what is the Fourier transformation of a function, because the kernel is e power minus ist, and it is its inverse. Always when you are talking of the integral transforms, you should always talk in pairs. One is the transformation, the another is its inverse. Okay. So for both the things, for easy convenience, I am using the same coefficient, because for some books you could find that in one of the things they will keep the coefficient as 1, in another thing they will take it as 1 by 2 pi, but I want to equally distribute so that you don't forget it. Okay, this is the Fourier transformation. Okay, but this I'm not going to explain what is the Fourier transformation, etc. My focal point is how you are getting the caller ID, which is a number, right? 10 plus digit number in your mobile phone with the name associated, voice, everything. Okay. So this is what the mobile phone. The keypad, okay, the keypad of the mobile phone consisting of a matrix, right? So it has a numbers and the hash and the star. It has numbers from 0 to 9 and 2 other symbols. One is star and the another is for the hash. Okay. So therefore, it is in fact a 4 cross 3 matrix. Okay. Now, if you press each number, a frequency is generated. Okay. So this as I'm borrowing some electronic things also. So when you press a number, there will be 2 frequencies generated. One is called the column frequency. The another is called the row frequency. So these 2 frequencies uniquely fixes the number. Uniquely fixes the number. And because it generates 2 frequencies, the technology associated with what I'm going to speak on is called DTMF frequency technology. So what is the expansion for the DTMF? It is dual tone multi-frequency. Dual tone multi-frequency technology. So when all the 10 plus 10 numbers are pressed, if you are calling anybody in India, 10 numbers suffice. If you are calling somebody in the other foreign countries, you require their code, country code, area code, like that. Okay. So a combined time curve will be formed and you take a Fourier transform of that combined thing. It's in fact not a Fourier transformation, but it is we as mathematicians, we call it as a finite Fourier transformation, but the technologists or the electronics engineers, they call it as a fast Fourier transform algorithm. Fast Fourier algorithm. Okay. So this curve will be like this. Okay. Now, if you look at the peaks, so how many peaks are there? Make a counting. Depending on you get the peak, that many numbers have been dialed. That is one conclusion. And the second thing is each peak corresponds to the combined frequency of certain number, right? So there is a mechanism built in your phone, in your mobile phone, to receive that frequency and identifying the number. And another thing is equipped in your mobile phone to throw the number into a display. Now, all these things are happening in a microseconds. In few microseconds. Okay? The display mechanism will display the number. If that number is associated with a photograph or a name, that also will be displayed to you, so that you can decide whether to attend the call or not to attend the call. Okay? So a simple Fourier transformation is behind the mobile phone. So the next time when you look at the mobile phone and you get the caller ID, please remember, as mathematician, it is a mathematical work which brings you the caller ID. Okay? Right. So thank you. But anyway, due to the restriction of time, I cannot proceed the other things. In fact, I wanted to tell you about the football also. Football and the... Okay. I'll just do it with one message. I'll end up the thing with a message. Please remember, all the Tamil speaking friends, துணிப்பை என்பது எளிதானது, தூர எறிந்தால் உரமாவது. பிளாஸ்டிக் என்பது அழகானது, விட்டு எறிந்தால் விஷமாவது. Please avoid plastics. So friends, mathematics is an interesting language, as I've been telling you. Come, learn, enjoy, and enrich it. So if you have any questions or any doubts, or if you feel that what I have told you is not, you are not able to understand, you could always contact me through my email. Wait for 24 hours, I will reply. Okay? So hope you know what is this formula. Sin q by cos q, which is thank you. So this is my email. I am also very active in the Facebook, where my full name is there. Okay, so where I share a lot of my personal things, and also the little bit mathematics also I share in my Facebook. Okay, so thank you very much once again. The Guru Nanak College, that is where I started my college the first time in 1971. And I'm very happy to share the knowledge through the organization of Guru Nanak College. Thank you very much, sir.
Sir, we are really sorry to have cut short. I'm sure the participants would love to hear more, just like I do. But due to time constraint, we weren't able to move on to the next segment.
Yeah.
Thank you very much, sir, for your enlightening talk. Be it 5 teaching habits or 8 wonders of scientific or mathematical wonder world, and 9 steps to be an effective teacher, each one is a precious concept on its own. And we are sure that all the participants had a great enriching experience through your talk. Your insights truly showed us how mathematics shapes our everyday world. Thank you once again, sir.
Yeah, thank you very much. Wish you all the best.
So participants can feel free to post questions in the chat box. If you have any doubts or queries, you can message in the chat box.
Okay.
So we've got a lot of feedback, such as excellent session, sir. Thank you so much. And we have one participant who shared that wish to have the second PPT or subject session again, Professor. Sure, when we get time, once again, let's do it again. So we have another feedback, interesting session, sir. Thank you, sir.
Yeah.
Participants, if you have any doubts, you can just post it in the chat box.
Sure. Yeah. Thank you very much. Thank you. Yeah, somebody is asking about the cryptography. And they are asking also my LinkedIn ID. I don't remember. I was having LinkedIn, but anyway, I will share that also. LinkedIn ID. Wish to have the second PPT, a separate session. Again, Professor, thank you. Thank you, Virarajan, my friend. Okay. So I think, can I close it now?
Sir, thank you, sir.
Yes, sir. Thank you, sir.
Because we need to continue with the second
Okay, sir.
lecture, right?
Thank you, sir.
Yeah. Yeah. So I'll mute myself.
Hello.
Yes, ma'am. We are just having a technical issue. We are starting into
Moving on, we are delighted to have the second speaker of today's session. With us, Dr. Kavita Sutar Deshpande. I now invite Mr. S. Ganesh, Assistant Professor, PG Department of Mathematics, GNC, to introduce our esteemed resource person to the gathering.
Good afternoon, everyone. It is my great pleasure to introduce Dr. Kavita, a freelance mathematician and a visiting faculty at the Chennai Mathematical Institute, Chennai. She is also an industrial computing and computer vision. She is a faculty of Math Circle, Chennai chapter. Other teaching roles she played in her past includes being an associate professor at Sai University and various roles at the Chennai Mathematical Institute, such as lecturer, adjunct professor, and a visiting fellow. Her research interests include numerical linear algebra, representation theory, combinatorics, scientific computing, and computer vision. The quality of her research is evident from her publications in top journals, including the Journal of Ramanujan Mathematical Society and the Journal of Commutative Algebra. She also played the role of a referee for Journal of Algebra, one of the top journals for pure mathematics. She is also a reviewer for Central Math and for Mathematical Reviews, American Mathematical Society. She was a faculty advisor for MSc Data Science program at CMI, and apart from her pivotal role in academia, she was also a member of the Grievance Committee and Admission Committee at the CMI. Being a wonderful mentor and a faculty member, she has a prolific experience in teaching courses such as computer vision, multiple view geometry, introduction to cryptography, theory of computation, numerical methods, pre-calculus and calculus, data analysis and visualization, computer vision, linear algebra and its application, mathematical methods, representation theory of finite groups. She is an expert in providing consultancy services to various scientific industries. Several communities have benefited from her expertise, including the teaching community at large through her outreach and FDP programs. Some of the consultancy projects include the following: executive coaching in linear algebra, machine learning, and artificial intelligence, FDP workshop leader in linear algebra that enables educators to prepare for data science and AI industry demands. Machine vision algorithm for precision measurements for industrial components, scientific computing, wavefront analysis for corneal topography, path planning algorithm for drone flights, analysis of drone images for crop counting. She has delivered lectures at leading universities in various parts of India, including Hyderabad, Pune, Bangalore, Chennai, and across the globe, including USA, Canada, Brazil, Mexico, and many more. She has been a faculty member of the Math Circle, conducting classes for middle and high school students since 2012. She was a resource person at the Epsilon camp with Raising a Mathematician Foundation on the topic Wallpaper Group, and she delivered various talks at several training programs with the RAM Foundation. She was a speaker at the origami workshop organized by Sri Pancham Kemraj Mahavidyalaya, where she delivered a talk on the topic origami and geometry in 2021. She presented a talk on kaleidoscopes and reflection under STEM's lecture series 2020. While the list goes on and on, in the interest of time, we now thank Dr. Kavita for accepting our invitation without any hesitation, and we warmly welcome her to deliver her talk for this webinar. Thank you. Ma'am, the stage is yours.
Sorry. Thank you, Ganesh sir, for the generous introduction. Again, in the interest of time, I'll quickly start. I will share my screen. While everybody might have seen the title of the talk, what I would like to know before we begin is who is my audience here, right? So there are, I think there's a mix of undergraduate students, postgraduate students, and faculty. Is that right?
Yes, ma'am. That's perfect.
Okay. So yes. So I will be talking about mathematics in general, my experience with mathematics, and why I think that it is possible for everyone to have their contribution, enjoy this knowledge without without any anxiety or fear to hold them back. Okay, it is something that is possible for everyone, but I think there are many things that hold us back, and I want to talk about a few of those things today. Okay, so just as a warm-up, let's think about why mathematics matters, right? I mean, sometimes you might think, if I want to do any calculations, I have a calculator. Or if I want to do any complicated calculations, I have a computer, right? So why should I care about doing any mathematics at all, right? So for a long time, people have wondered, and that all that constitutes mathematics? Is calculations the only thing that mathematics offers? So that's not true. I mean, mathematics is more than simply some formulas that you can compute with a calculator or a computer. It goes deeper. It is a way of thinking, right? And this is what people have discovered over the past decades, that mathematics not only provides you ways, algorithms, formulas, methods to solve problems, but it is also a way of thinking, right? So why do we say it is a way of thinking? So when you do mathematics, maybe you have done your calculus courses, or maybe you have done linear algebra, differentiations, whatever. In any of these courses, you see that there is a language of mathematics that comes in. What constitutes language of mathematics? So suppose I want to start talking today about vector spaces. Okay, just as an example. Will everybody understand vector spaces here? Is that word familiar to everyone here? Okay. So suppose I want to talk about vector spaces. Then how do I build that language? Okay. So in today's world, if you want to enter any of these AI, ML kind of areas or data analysis, then linear algebra is the language. That's what everybody says. And you must have heard this from other people also, right? So first of all, it's a language. Who's there? See, in language, we have vocabulary, right? We have words in a language. So in the language of a subject like mathematics, the words will be definitions. Okay, definitions correspond to words. Is the vocabulary of a language. Okay, and you can think of results or theorems or any interesting properties. Okay, all of that constitutes. So results, theorems, all of this constitutes grammar of the language. You can just think of this correspondence in this way. And then mathematics, for example, the study of vector spaces is sort of a new language. Now, why is that language important? That language is important because it models a lot of real life problems. Okay, so I'm going to show you 2 or 3 problems today. And I try to convince you that it models real life problems. And therefore, it is useful to know the language of vector spaces. It is useful to know the language of calculus. If you know that language, then there are many things that you can express. Right? As you grow up and you learn your mother tongue, maybe when you were a kid, you weren't able to say a few things. But when you grow up, you're able to properly say that in a complete sentence because you have learned the language. Right? Similarly, when one is studying systems in real life, right? And these systems, in the previous lecture, Professor Shanmugam has given you so many examples, right? So this is also what he was trying to say, that in all these various examples, all this can be expressed with the language of mathematics. So certain problems can be expressed with linear algebra, certain problems can be expressed with the language of functions, right? Various things. So basically, it is like learning a language. It is a way of thinking because in mathematics, there is also a lot of importance to precision. What is precision? I don't mean in the machine learning sense. I mean as an English word. What is precision? Precision means saying something exactly what you mean. Okay, saying something correctly or expressing something correctly. It should be exactly what you mean to say. So, for example, if you, I think everybody's nemesis at some point, okay, is this epsilon delta definition of limits, right? Everybody probably has seen this epsilon delta definition of limits at some point. And for everybody, it has been a headache at some point, okay? But that definition is a very good example of how to say something with precision, okay? So you use, when you learn this, when you learn mathematics in this way, you understand the real meaning of words like for every, right? What does it mean to prove for every? What does it mean there exists? Okay, there exists. So what is the difference between these two? Okay, what is the logical difference between saying these two? Okay, so there is importance to precision and there is importance to logic. So when you study whatever course in mathematics that you study, you are also behind your mathematics problems. You are also learning these skills. Okay, whether or not your professor tells you explicitly that you are learning this learning is going on. Okay, your brain is picking up the language, your brain is understanding the importance of saying something properly using the precise words, and your brain is also understanding how to arrange your argument, your logic properly using that language. So these are skills, okay? No matter what math course you do real analysis, complex analysis, differential equations, graph theory, combinatorics, whatever you do, you are picking up these skills without actually knowing it. Okay, maybe you have not formally acknowledge that you have picked up these skills. But when you do more and more math courses, when you do this kind of thinking, you pick up these skills. And it is these skills that are sometimes just as important as the courses that you study. Okay, and this is not acknowledged commonly. Okay, it is not just your problem solving skill that is important, but it is these kind of skills which you don't see directly, but you keep on building. Your brain starts to think in this way without you formally realizing it. Maybe you have not acknowledged it, but it builds up in you. Okay, and that building up is why studying mathematics is still important in the age of computers. In fact, it has become even more important to understand what computers do. But you know, the thought that people have, you know, we have all these computing machines, then why should I learn mathematics? Why should I spend my time doing this? It is not just because you want to know some formulas and you want to do some computing. No, it is because these skills are developed along with learning whatever mathematical subject, geometry, algebra in school, calculus in college. Okay, whatever you might be learning, you are inadvertently, without knowing it, developing these skills, this way of thinking. And this way of thinking is more important sometimes than knowing actually calculus formula. Okay, you might not remember your integration formula, but if you have these skills, you can anytime go back, okay, and understand and read. Okay, so more than formulas, it's a way of thinking, and that way of thinking is what you want to develop, and that is why mathematics matters. Okay, on another practical level, okay, mathematics can shape careers, it shapes technology, and it shapes innovation. So careers, okay, I will talk a little bit about careers as I go forward in this talk. Technology, Professor Shanmugam told you so many examples of how mathematics is used in technology. I will show you a couple of examples. Innovation. Now, in innovation, how is mathematics used? So, very simple example of innovation. Again, it comes down to understanding these skills. Okay, so logic is what will help you connect different ideas. Okay, so connect. For example, how did people come up with ChatGPT? Everybody uses ChatGPT, right? Nowadays, everybody uses GPT, right? So how did the scientists who came up with this model come up with it? Because before this, there were a number of developments. This is not the first GPT, right? There were many GPTs before this. But this previous GPTs plus new ideas, people have kept on building on this, and the result is that now we have something like ChatGPT, whose versions are also increasing. Okay, what do you think that goes behind building all of this? A lot of linear algebra, a lot of calculus. Okay, these are the things that go behind building any of these AI models. So that's just one example. Okay, I will give you some more examples of innovation. And this third thing, I think, is most important, that mathematics, because it is a language in which a real life problems are expressed in science, so it has a foundation for many kind of problem solving models. Okay, suppose you want to model how a drug is delivered in the body. Okay, in drug delivery, in pharmacology, they study how drug is delivered in the body. Once you take a medicine, how does your body absorb it? Okay, so that the chain reactions have to be modeled. Okay, so that is just one example. Or you want to do 3D reconstruction from images. Okay, so anything that you want to do, first it has to be, so you have a real life problem, then people build a mathematical model of it, and then you go ahead and solve it. So the part where people build a mathematical model for a problem uses exactly mathematical language, uses the language of calculus, linear algebra, these subjects that you have studied before, combinatorics, graph theory. All these areas come into the this problem solving. Okay. And of course, more common areas like engineering, everything in engineering is modeled as a mathematical problem. Okay. All right. So these are some generalities, but now let me get into some specifics. So before we go ahead, I want to ask you a quick question. Okay, so we all easily we say if you ask anybody, do you like math? Then they will probably say no, I hate math, and it has become a fashion to say, oh, I hate math, I don't like it. So in my audience, can I take a quick poll and ask how many of you think you love? So what do you mean by love mathematics? It means that suppose your favorite TV program is on and your friend comes with a math problem, you're still willing to go and do that math problem, then look at your favorite TV program. That is when you say you love the subject, right? Because you're willing, you like it so much that you're willing to put away something else that you like and go and solve a problem, think about it. So how many people here think they love mathematics? No answers. You would rather watch your video than go and solve a math problem.
No, unfortunately, they're all muted. They can put the response in the chat, actually.
Yeah. Okay, at least there is at least one participant who says that they love math. Okay, so all these people, even if they have their favorite movie going on or whatever, if they are asked to solve a math problem, they will go and do it. Right? Okay. Okay, so I'm very happy to see that there are more and more answers coming up. So about we eat math, sleep math, live with math. Okay, that's lovely. Yeah, so now I am seeing that there is somebody who says I fear maths, right? Some people tolerate math, which means they don't like math, but they tolerate, they still study it because they know that it is going to be, everybody says it is useful, it is required, it is, you need to score in it to go to engineering and this, some reason or the other, right? So that is tolerating. Okay. So some people don't hate it, don't love it, but they tolerate it. They'll be like, okay, I'll live with it. I'll do it because it needs to be done. Right. So there are people who tolerate, there are people who love math, and some people secretly fear it. Okay. And what I want to say is that this fear of math is more common than what I'm seeing in my audience here. My audience here seems to be more tuned into mathematics, or maybe they want to make their professors happy. I don't know. But so, and what I will say you really should get some handle on is optimization. Okay. Optimization in single variable, multiple variables also. Okay. So optimization, also let me say multivariable optimization. Multivariable optimization, where you talk about, Hessian and the conjugate gradient method, gradient descent and this kind of methods. Okay. So I would say that someone who is very good at these, right? If you are well trained in these areas of mathematics, you can fit into a lot of domains. Okay. What different domains? There are many different domains. So there is drone technology. There is cryptography and, fraud detection technology. There is AI, there is machine learning. There is data science where you want to do predictions from some data that is given to you. There are so many areas. There is finance. Okay. There is actuarial science, what I've mentioned here. Anything, if you have a skill set, strong skill set in these areas, okay, you can take your skill set. I'm not saying just the understanding of the subject. I talked about these skills, right, in the beginning, right? So in the beginning, we talked about all these skills. You can take your skill set and go into any of these domains and help. Okay, you can find job in any of these domains if you are good at these areas of mathematics. Okay. So there are a lot of career prospects. I had a few more slides about details about these, and I will share these with your professors. Okay, so I will not talk about that. But finally, I would like to talk about why you should go for higher education. Suppose you are an undergraduate student or a postgraduate student, then why you should go and study a bit more. So definitely it opens up better paying and fulfilling careers for you. That is one very obvious use of going into higher education, where you want to really deepen your understanding of whatever subject that you might be studying. A deeper exploration of mathematics. So, there are people in the industry, there are lots of engineers in the industry, and they are working on really cutting edge technology, but not everybody understands the mathematics that goes behind these. Okay, and in fact, there are a lot of people with math anxiety or math apathy in the industry also, and they don't really have the time or the energy to go into that mathematics. That is a gap that math majors can fulfill. If you are an undergraduate math major or a postgraduate math major, if you demonstrate or if you really develop your math skills so that you can fill those gaps for people will welcome you into industry. Okay, so these subjects that I mentioned, right, all these subjects, if you have a really deep understanding of all this, see what is backpropagation. Backpropagation is the core algorithm in deep learning. It is based on linear algebra and multivariable calculus. Okay, all of deep learning, lot of machine learning problems are essentially optimization problems. Okay, so if you can get a very good understanding of these areas, you will be able to fill the gap that those people in the industry are not able to with mathematics. Okay, that will open up a lot of opportunities for you. Okay, and yes, there is you can get global exposure by when you go into higher education. You start to read more, right? You probably, if you go, I'm not saying everybody needs to go for a PhD, but you read journals, you read more, you meet more people, okay, and you get to see what kind of research goes on. So even when you're a student, you should try to think, what do people do in this area currently? Okay, what is the use of what I'm learning? How do people use this in cutting edge technology? So when you think about these things, you improve your exposure also. Okay, and this is I just added because I thought it is an interesting thing to say, which is true, that education compounds like interest, like compound interest, right? So in the beginning, it might feel like you're learning very slowly. Okay, and the benefits are also very little. But as you go on building, not only do you learn faster because you have a foundation, but the benefits also go on improving. Okay, so it is true that education does compound. It is like compound interest, not simple interest. It really, when you have your basics straightened out, then the learning also becomes much faster. But in the beginning, you have to remember, you have to think, you have to practice, you have to internalize concepts. Without that, you cannot really get into that zone, that deep zone where you can actually solve problems for other people. Okay, all right, so I just want to end by saying that, well, math will open many doors for you as it has done for me. Okay, so I used to be a pure mathematician. I worked in representation theory, if anybody has heard of it. And in 2018, it was there was a drone company that came to CMI, and they had a very interesting problem. And that problem was in computer vision. And I didn't know anything about computer vision at the point. Okay, but the problem sounded interesting, right? So I thought to myself, well, it will be so nice if one can solve the problem. The problem was that they are going to fly a drone on a field of corn, and one has to count the plants in that field. And I thought, wow, that is such an interesting problem. It will be so nice if this can be done. And even though I knew nothing about the area, I told those people that, look, I'm interested in solving this problem, but I don't know much. Will you let me work on this? And they were nice enough to say yes. And that is how I got into computer vision. And now I offer courses on computer vision. Right. So one thing that you should keep in mind is that you shouldn't let what you don't know decide your future, but keep your mind open. Okay. Don't let anxiety take over your life, but you manage it. Try to get over it. Don't stop early. Learn more, pursue some higher education, get better degrees. Okay. And then it will open up doors for you. And this is the last and most important thing. We need more problem solvers. We don't need people who, given a solution, you produce more and more of a product. So we already have enough of those. We need more problem solvers. And India has enough really good brains. Okay. So if we can get them to solve our problems, that is what we need. Okay, so thank you very much for listening patiently. I'm definitely, 15 minutes over time. People must be getting impatient here. So let me stop. Let me ask if you have any questions, and some other time I will be willing to show you the applications of vector spaces. Okay, thank you for listening. Any questions, comments? I'll be willing to take. Yes, I will share the PPT. Thank you. Yeah, so it looks like there are no questions. Let me thank the organizers for inviting me to interact with your students and faculty. So is Professor Ganesh here? I would just like to say thank you and bye. Thank you. Thanks. Suggestions to children who are studying in schools? In what context? What can I generally suggest to them? Play more. Go out and play. Don't sit in front of the TV. Is that the kind of suggestion you're looking for? Yes, so this book, How to Solve Bipolar, is really, really an amazing book. Okay. And then why Johnny can't add? Yeah, I don't know about this book, but I will look it up. Thank you for the suggestion. Okay, thank you. So maybe I will sign off. If anybody has in the government sector side. I'm sorry to disappoint you, but I'm not really an expert on the government sector. I really know more about the technology sector because I consult in the technology sector, and my students also have gone in that area. So I don't know. I'm afraid I don't know much about the government sector side. ISRO and DRDO, I can say something, but I cannot say anything about UPSC or those kind of exams. But right in the beginning, I told you, right, it is the skills that mathematics brings into you as a person, which can be applied in any area. Any data analysis course for MSc student? Data analysis course as in online or offline? IIT Madras offers a wonderful BTech in data science. IIT Madras BTech in data science is a very good course that I know. And if you want to, there are very good courses on NPTEL. NPTEL, people have heard of NPTEL. By the way, for there is one YouTube channel called 3 Blue 1 Brown. And this is very good for concepts in calculus, linear algebra, machine learning, and general math concepts. Okay, so 3 Blue 1 Brown is a very good YouTube channel that I will recommend. I will also recommend you to this YouTube channel by this IIT professor. I think his name is Mahesh. Just give me 1 second. I will bring it up again. This professor from IIT Madras has been giving lovely lectures on what are the areas where there are cutting edge careers. Okay, so I will tell you. Yeah, Professor Mahesh. Okay, YouTube. Look up his channel on YouTube. What is it called? I don't know. Okay, I think it is called Professor Mahesh only. Okay, so look up his YouTube channel. And I think he has done an excellent job of bringing people to talk about what are the cutting edge technologies and careers for students today. Okay, he started his channel as a career counseling for students. Okay, so excellent channel. Just have the patience to listen what he is saying. Okay, it's a very nice channel. Okay, so Ganesh sir wants us to wait for a few minutes. So in the meantime, can I show you something interesting?
Yeah, because the participants are asking for feedback forms. I said to them, just wait for a few minutes. We will wrap it up the session.
Yeah, I am done actually. If you need some time, I can show them something interesting.
We just have a formal vote of thanks, ma'am. Before that, I request all the participants to turn on their video so that we can have a virtual photo session. Hi, ma'am.
Yeah, hello.
Hello, sir. Thank you everyone for switching on the camera.
Yeah, I do wish the cameras were on earlier, then I would have
all the time. I know. Thank you, participants. Just a second. Well, the camera is still on. I think we can request Ms. Jyoti, who will formally deliver the vote of address today.
With this, we come to the final part of today's program. I now request Ms. Jyoti to deliver the vote of thanks.
Good evening, everyone. It is my honor to deliver the vote of thanks for today's enriching session. I begin by extending the deepest gratitude to our distinguished speakers, Dr. T.N. Shanmugam, Professor, retired Anna University, and Dr. Kavita Sudha Deshpande, freelance mathematician and visiting faculty at CMI, for accepting our invitation and sharing your knowledge with us. Your sessions were highly informative, thought-provoking, and inspiring. We truly gained a lot from your expertise. Next, I extend my sincere thanks to General Secretary and Correspondent, Mr. Manjit Singh Nair, whose constant encouragement and vision made this program possible. I also wish to thank our respected principal in charge, Dr. R.M. Edilarisi, for her guidance and support, which has been a pillar of strength for organizing such events. Further, I extend a heartfelt thanks to our Vice Principal, Dr. P.V. Kumarabul, whose encouragement and constant support paved the way for this program's success. I would also like to place on record our gratitude to Dr. Swati Paliwal, Dean Academics, and Dr. J. Jayanti, School of Sciences, who joined us today. Your presence added prestige to this event and reminded us of the strong bonds that continue to inspire our institution. I would like to express my sincere gratitude to our head of the department, Dr. K. Manikandan, for his guidance, support, and encouragement. Our deep appreciation goes to the organizing committee and technical team for their tireless efforts behind the scenes. Your planning and coordination ensured the smooth flow of today's event. I must also thank our moderator or host, who wonderfully steered the session, kept the discussion engaging, and maintained the momentum throughout. And above all, a very special thanks to our participants. Your enthusiasm, active involvement, and thoughtful questions made this webinar meaningful. Without your participation, the event would not have been a success. Finally, I thank each and everyone who has contributed directly or indirectly to the success of this program. With gratitude in my heart, I once again thank everyone for making today's webinar a memorable one. Thank you and wishing you all the very best.
Thank you.
Thank you, Ms. Jyoti.
Thank you.
I now request all the participants are now requested to fill in the Google form, scanning the displayed QR code posted in the chat box. The form is open for the next 30 minutes, so kindly fill it and get your certificates. Look out for our upcoming event, hands-on workshop.
Yeah, we thank from our heart for your time, respected ma'am. We thank with our deepest gratitude for your time. Thank you very much, sir. And
Thank you for the invitation.
thank you.
Thank you, sir.
Okay, thank you very much.
Thank you
Sir
for joining
Ganesh.
us.
Yeah. Thank you.
Thank you, sir.
Shall we?
Right. Should
Yes, sir.
we?
Yes, sir. You may sign off.
Okay.
Yeah, you may sign off. Thank you. Thank you.
Yeah.
Okay.
Thank you very much. Yeah. அது photo எடுத்துட்டீங்களா?
Yes, sir.
Yes, sir. Yes, sir.
Okay. And then you can also send it to us.
Yes, sir. Definitely.
The
we'll
group
share it with
photo,
you.
you can send it to us.
Sure, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.